All right. So today we have something fun and probably tormenting to business students. Don't know why you have to learn it, but it's part of your curriculum. So let's just have fun with it. It's called integration by parts. So when an integral is too difficult or impossible to integrate with standard formulas, we use integration by parts to make the integral easier. So we have to pick u and v. So here's the formula for integration by parts. It's the integral of u dv equal to uv minus the integral of v du. Okay, so this is what we're going to be using. And to set it up, we have to find out what u and dv are. So we need to know which one to pick for u and which one to pick for dv. So that's going to be our setup. And then once we find u and dv, we will then follow this formula here. Okay. So number one, we have the integral of 4x e to the 5x dx. Okay. So one thing I can say about this, because I've done it many times, if you're ever given the form of the integral of x to the n e to the x, anytime you get this form, it's always wise to let u equal x to the n and let dv equal e to the x. So always, 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 if you get this form. And again, we have the time, so I can show you what happens if you go the other route. So if you ever look at that form, you'll know how to set it up. Okay, so what we're going to do here, let me lower that, is that we're going to let u equal 4 to the x, and then we're going to let dv equal e to the 5x. Okay, so we have our u labeled, we have our dv labeled, and now here comes the fun part. So for the u's, you are going to take the derivative. For the dv's, you are going to integrate. Okay, so once we do that, the derivative of 4x is going to be du equals 4 dx. And then we're going to take the antiderivative of e to the 5x, and the antiderivative of dv becomes v, and the antiderivative of e to the 5x is going to be 1 over 5 e to the 5x. So these are in our formulas that we learned in 12.1, 12.2, 12.5. Okay. So now, since we have u, du, dv, and v, we can now follow the formula above. Okay, and I'll even write it out. So this becomes uv minus the integral of v du. And now match everything up. You're going to get u times v, 4x times 1/5 e to the 5x minus the integral of v times du. So v times du. So that is 1/5 oops, yeah, 1/5 times e to the 5x, and du is 4 dx. Why did I put that in its own? There we go. 1/5 e to the 5x times 4 dx. Okay, there we go. We have followed the integration by parts formula. Let's go ahead and clean this up a little bit. We'll start with the first term. This 4x times 1/5 e to the 5x becomes 4/5 x e to the 5x minus, and now we're going to go ahead and clean this up. So here, I'll rewrite this integral really fast. So 1/5 e to the 5x times 4 dx becomes 4/5 e to the 5x dx. That 4 and that 1/5 just multiply. Okay. One more rewrite here. 4/5 x e to the 5x minus, and I'm going to take out that 4/5 and multiply it by the integral of e to the 5x dx. Okay. We are all set. The first term is good. All we have to worry about is now finding the antiderivative of e to the 5x again. Okay. So rewrite everything one more time. 4/5 x e to the 5x minus 4/5 times, and once again, the antiderivative of e to the 5x is 1/5 e to the 5x, and tack on that c. All right, one last cleanup, and we will get 4/5 x e to the 5x minus 4/5 times 1/5 is 4/25 e to the 5x plus c. There we go. And that is the antiderivative of 4x e to the 5x. All good fun. Okay. So what if we chose it the other way around? Again, it's all about practice. How do you know which terms to choose for u and dv? Let's say you let u equal e to the 5x, and then you let dv equal 4x. Okay, well then if you took the derivative here, you'd get 5e to the 5x, and then if you took the integral here, you get 4 times x squared over 2, which would give us 2x squared. So if you put this back into the integration by parts formula, you'd end up with e to the 5x, so uv, so e to the 5x times 2x squared minus the integral of v du, and it'd be 2x squared 5e to the 5x dx. Okay, now what happens here is that you now have these two terms inside, which means the integral is going to keep going. You're going to end up in an endless cycle, because if I clean this up, you'd have -10 times the integral of x squared e to the 5x. And if you did it again, you would keep going continuously. So that's how you would know that you messed up the labeling of u and dv, if the integral keeps going and going and going, because you would have to integrate this by parts again. And then the next one would probably be the integral of x cubed over 3 times e to the 5x again, and then it would just keep going. So that means if it keeps going, you keep going down the rabbit hole, stop and relabel u and dv, so you can actually end up at an answer. Okay. So again, and it's all about practice, but just delete that. There we go. But a quick and easy tip for you guys. Once again, if you're ever given the form x to the n e to the x dx, u is always going to be x to the n, and dv should always be e to the x. So that's your little tip there. Okay. Next one. All right, 2. We have the integral of x cubed natural log of x. So in this form, well, we are going to let u equal the natural log of x this time, and dv is going to be x cubed. And the reason for this is that if you let dv equal the natural log of x, we're going to have a really difficult time figuring out what the antiderivative of the natural log is. So we know that the derivative of the natural log, oops, over here, is 1 over x. And we know that the integral of 1 over x is the natural log of x. But we have no idea what the integral of the natural log of x is. Therefore, we let u equal the natural log of x this time, and dv equal x cubed. There is an integral to the natural log of x, but we're not going there. Okay, so there's that. dv equals 1 over x dx, and then the antiderivative. So remember that this is derivative, this is integrate, and then the antiderivative of x cubed is x to the 4th over 4. And now let's follow our integration by parts. You're going to get u times v, the natural log of x, times x to the 4th over 4, minus the integral of v du, x to the 4th over 4, times 1 over x dx. There we go. Clean up, and we'll have 1/4 x to the 4th natural log x minus, and then what's going on in here is that, here, I guess I could do a little side work over here. What happens here is that you can rewrite this as 1/4 times x to the 4th times 1 over x. So I'm just rewriting everything on the inside, which then becomes 1/4 times x cubed. Or if we need to see that other step, it becomes 1/4 times x to the 4th over x, which becomes 1/4 times x cubed. There we go. So now, when I rewrite this integral, I'm going to pull that 1/4 out, and you're going to have 1/4 times the integral of x cubed dx. Okay. And now we just need to find this antiderivative, and it's a lot easier now. All we have to use is power rule, and you'll get 1/4 x to the 4th times the natural log of x minus 1/4 times the antiderivative of x cubed, which is x to the 4th over 4 plus c. And one last cleanup, 1/4 x to the 4th natural log x minus 1 over 16 x to the 4th plus c. Done and done. Also, if you're wondering how I rewrote natural log x of x over 4 to the 4, well, once again, that's a 1/4 that I can take out. So I'd get 1/4 times natural log x times x to the 4th. And then I just rearrange it and put it as 1/4 x to the 4th natural log x, which was that piece. Or sorry, not that piece. That piece right there. Okay, I probably can leave those in there. That's good. Okay, so there's those. Last one. Ever for this class. Last problem. So here on this problem, some problems require to use integration by parts multiple times. We repeat until we produce a simpler integral. Okay, well, this is one of the tips, right? This is in the form of the integral of x to the n e to the x dx. And remember, if it's in that form, then we always let u equal x to the n. So here, u is going to equal x squared, and then dv is going to equal e to the 2x. So that was just like the first problem we worked today. Okay, and then remember, we derive and we integrate. So the derivative of x squared, du equals 2x. The integral, the antiderivative of e to the 2x, is 1/2 e to the 2x. Okay, and again, if you're wondering where that antiderivative comes from, if you look at your notes, there's an integral of e to the ax, which is this antiderivative of 1/a e to the ax. So that's where I'm getting it from. It's in the formulas we've learned in the previous sections. Okay, we are ready to set up our integral by parts. So it's u times v, x squared times 1/2 e to the 2x minus the integral of v du. Or you can even say, what does teachers do to make it sound cool? They say voodoo. You have 1/2 e to the 2x. Oh yeah, and don't forget your dx on these derivatives. There we go. 1/2 e to the 2x times 2x dx. Okay, we've got some cleaning up to do. So on this first term, x squared 1/2 e to the 2x, I'm just going to pull that 1/2 to the front. That's it. And you're going to get 1/2 x squared e to the 2x minus, and now on this term, we see that I have 1/2 and I have 2x. So here, let me do a little side work. I have the room. I can rewrite this as 1/2 times 2x times e to the 2x dx. All they did was move the 1/2 and the 2x to the front, which means 1/2 and 2 will cancel, and I'll be left with x e to the 2x dx. And that's what I'm going to put in this next integral. The integral of x e to the 2x dx. Okay, perfect. But now we once again see we have this special form. This is the form that we saw earlier. This is still x to the n e to the, oops, not e to the 2x, e to the x dx, which means we have to integrate by parts one more time. So here, I'll choose different colors. Let's see. Green. U is going to be x, and then dv is going to be e to the 2x. Take the derivatives, du equals 1 dx. So this is derivative. Remember, this is integrate, and v is going to be again 1/2 e to the 2x. All right, and here we go again. So this stays put. let me write below so I don't run out of room. 1/2 x squared e to the 2x minus, and I'm going to put a bracket here to be neat, because what we're doing is integration by parts again. All right, and now following the formula, u times v, x times 1/2 e to the 2x minus the integral of v du. 1/2 e to the 2x times 1 dx. Close bracket. Okay. Clean up, clean up, clean up. I get 1/2 x squared e to the 2x minus, and then on this term, I'm just going to pull that 1/2 to the front, and you'll get 1/2 x e to the 2x plus, so remember this negative is going to both terms, plus, and then this just becomes, that's 1/2 e to the x times 1, which is just 1/2 e to the x. But I'm going to pull that 1/2 out. So you're going to get 1/2 times the integral of e to the 2x dx. Okay. And now we have reached an easier integral. We no longer have the integration by parts because e to the 2x is all by itself. So we just find that antiderivative and we clean up and we should be done. 1/2 x squared times e to the 2x minus 1/2 x e to the 2x plus 1/2 times the antiderivative of e to the 2x, which we've done 2 times already. This will be 1/2 e to the 2x plus c. Final cleanup, 1/2 x squared e to the 2x minus 1/2 x e to the 2x plus 1/4 e to the 2x plus c. Boom, boom, boom. And there it is, double integration by parts. And that is it. That is our last lesson, guys.